So this is the chi-squared test of independence, not chi-squared, it's chi-squared. Okay, so this is what the chi-squared test of independence is, and a lot of you guys are actually going to use this one. So we use this test when comparing a variable of many levels with another categorical variable of many levels. So this can be major and gender, because major, there's a lot of major. Gender, if you have females, males, and other, then you have multiple categories. So this is basically just the extension of the Z test for proportions. So this is the chi-squared test of independence. Now here is gender associated with major, and we're going to be using the same exact data. Now, before we go to the data, I need to tell you what the null and the alternative is. So the null and the alternative is going to be the following. Okay, so this is what you would put. So for this one, you will H0 is going to be there is no association between major and gender. Okay, that is what your null hypothesis is. There's absolutely no association. They're not related. HA is going to be there is an association between major and gender. So there's no letters here. You literally have to write all of it down. Now here in red, I will say do not use correlation. Okay, do not use correlation for this. Don't do it. This is not what you want. You do not want to correlate things. Okay, you have two categorical variables. Categorical variables cannot be correlated. They can either be associated. Okay, there is some sort of association between the two. Okay, so hopefully that helps with a couple things. So you really do not use correlation. You will get marked down points if you say correlation. Okay, so the hypothesis, the null and the alternative is actually really easy to write out. You just literally write it in words. Okay, so now let's go to our data set. So we're looking for major and gender. So this is actually really simple. All you gotta do is you gotta click on stat, then click on tables, and then click on contingency with data. Okay, so the row and the column can be whatever you want. So I'm gonna choose gender, and then I'm gonna choose major. Okay, then this is going to be automatically selected, chi-squared test for independence, and then we're going to click on compute. And what happens here, it gives you a table. So it breaks down the gender with the major, and then it tells you here the chi-squared test results. And what you're really interested here is on the p-value. Okay, so let's write down the p-value, and then we'll talk about the warning. So p-value is 0.0229. Okay, so my p-value here, okay, so p-value is going to be 0.0229. Our alpha value in this case is 0.05. Okay, we can see that our p-value is slow. Okay, so we can reject HO, and we can say that there is an association between major and gender. So reject HO and conclude that there is an association. Okay, but where? Now the test is not going to tell you where it is. You can look at it and you can see that you tend to have more females in the humanities than STEM, and for males tend to have more in STEM than in humanities. So here you can kind of see a clear discrepancy. That's why their p-value is a little low. Now you have to be very careful with this, because you do have a warning. It says over 20% of the cells have an expected count less than 5. You can see that you have, for arts, you don't have a lot of samples. So if you don't want to see this warning sign is very crucial, because You really don't want that. You don't want to trust your p-value at this point because you have small samples in the arts. So you want to be very, very careful with this. Okay. So just keep in mind that if this warning sign pops up, you should not trust your results, or you should just either eliminate these arts if you think that they're not relevant. Now, one thing that you really also want to take a look at is the graphs. The graphs are really useful. You can just plot both gender and major. And I also want to show you guys one more thing. If you go back to our original z-test with males and alcohol habits, you can actually still use a chi-square test of independence. So you can use tables, contingency with data. So let's just do gender again, and let's do it with drinking, chi-square test of independence. And what you see is that it'll make a contingency table with the two levels that we did in the previous problem. And the p-value actually is the same as we had before with the z-test. So even if you have two categorical variables with two levels, you can still use a chi-square test of independence. It will still give you the same answer. So these two are just extensions of each other. They will give you the same p-value. Okay? So that's the chi-square test of independence.